go over some basic material. Start off with the information that all classes need to know, and at the end I'll let you know when I'm moving on to the honors material. There's a little bit where the honors students had to do a little bit extra. So let's start off with the basics. When you're answering these questions, you should pause it. You should be able to answer the questions now. If you're at this point, you're ready for the test. You're just trying to make sure that you remind yourself of a few things. So make sure you're not just watching this video and just writing down what I'm saying. Make sure you're actually doing the slides, maybe having a few blanks because you don't know exactly what I'm trying to get at, but then using the video to help you realize what I was trying to get at in the problem. Okay, so we have 23 meters per second east, which is a vector. There's two parts to make up this vector. The first part, it's underlined, is called the magnitude. So in a magnitude, what it's made up of is a number and a unit. So the meters per second will be included in 23 and meters per second would be included in the magnitude. And often on the E-class quizzes, if you're taking those with me, I'll often ask for the magnitude where I say, give me that number, give me the unit in the second blank, but don't worry about the second part, which here is bolded, and that's just going to be the direction. Okay, so if I was going to rewrite this information as a scalar quantity, I'm just going to go ahead and take that first part. So 23 meters per second would be an example of a scalar quantity because a scalar quantity only has magnitude. Okay, so these all come from the next slide. Which vector has the greatest south component? So here when you're looking at these, one's going east, one's going northeast, one's going south. Well, there's only one that has a south component right there. So there's no comparison right there. Then it says which is the greatest magnitude, and when you see a vector, there is a line which represents the magnitude and a direction representing the actual direction, the arrow tip. So these ones you're just looking pretty much for whichever one had the biggest line, and the biggest line right there is the winner is right there is A. So you don't have to know what the magnitude represents, the meters or meters per second, but that size would represent something. Okay, next part. We have a bird flying horizontally when it drops a fish. Draw the path that fish would take. So here's your little fish right there. And it's going to follow this projectile path because it's going forward constantly. At the same time, it's going to be accelerating downwards. The shape is called a parabola. And when would the bird have to drop the fish? Well, the bird is going to be going a velocity. And the fish is going to be going that same velocity because the bird has to be going the same velocity if it's actually holding the fish. So since the Vx is going to be the same, the fish is going to keep on going forward after it's dropped. So definitely it has to be dropped before the target so we can follow that parabolic shape. By the time the fish gets to this point right here, the bird's going to be over at this point. So, and that leads us to our next question. Because they're both traveling forward at the same rate, it doesn't matter. Once again, the y is independent of the x. Even though that y is increasing, it's still moving at a constant rate forward. So the bird would go this way, the fish would go that way, while the bird is going that way. Even though the fish is really doing this, the x component of velocity is going to be the same. The fish would be going at the same rate right below the bird the whole time. Once again, it's because of the velocity. They will both have the same Vx no matter what else is happening. So therefore, they're going to cover the same distance horizontally or forward. And so the bird will be directly above the fish when it does hit. So once again, if I'm going to draw that out, when the bird's right here, the fish will be right here. It's all because of the Vx being the same the whole time. Okay, so let's go ahead and look at some problems. Bird's flying at 25 meters per second when it drops the fish that falls 90 meters. So I'm just going to go ahead and start writing a givens list because I'm going to have things going on in the x-axis and in the y-axis. It's important to keep those familiar and in their own axes because they are going to be independent of each other. And the bird's flying at 25 meters per second. That is going to be a Vx equals 25 meters per second. So I'll be going forward 25 meters per second. And the fish itself is going to fall 90 meters per second. Or sorry, no, just 90 meters. So 90 meters right there. The fish will fall 90 meters into the water. And so since the bird is flying with the fish is actually going 25 meters per second the whole time right there. So let me go ahead and rewrite that, 25 meters per second. How long does it take the fish to fall into the water? So we need some more information in this y-axis to be able to answer that question, but we have that because we know that the fish is actually in the air. We know that, first of all, it didn't start down, it started straight forward. So it started with no downward velocity. So no initial y or up or down. Just a reminder here, when I talk right here, vertical, or I might say y-axis, I'm talking about the up or down. And when I'm talking about the x-axis, I'm saying either the words horizontal or x-axis. So when I'm talking vertical, I'm talking about anything in this y, and when I'm talking about horizontal, I'm talking about anything in this x, and I'm trying to keep them separate, once again, because they are independent. So the y is going to have gravity, 10 meters per second squared down, and this would be down as well. Just going off an old lesson when we had to decide when we have to have positive and negative values. Well, in this part, the basics of projectile motion, horizontal motion, they're all going to be going downwards the whole time. So we're going to stick to down, and so therefore you can either use both negatives or you can either use both positives. I'd rather use both positives if they, and just call down positive. So how long does it take the fish to fall? Okay, so there's an equation you can use to figure out the y-axis. So this is talking directly about how long does it take to fall or cover this y velocity. There's an equation you can use, t equals square root of 2y over g, and this can only be used if VIY equals 0. So a lot of students probably wonder why I've included this in every question when we hardly ever use it. Well, it's because you can't do this equation unless you have that the initial y-axis being 0. So you need to look for the words like horizontally shot, going horizontal. And so the t is going to be 2 times the 90. And that's going to be over g, which is going to be 10. So once again, if you were using negative values for down, you would have had both these negative. If you were using, like me, down being positive, because I'm not changing directions, I'm going down the whole time, I'm using positive values. So 2 times 90 divided by 10. Take the square root, and I get 4.24 seconds. So that's the time it takes to go down. So I'm going to add that to my givens, those 4.24 seconds. I'm also going to add it to this because we're going to need to solve for something else a little bit later. So t equals 4.24 seconds. That's how long it has to go down. It's how long it has to go forward, and the end result is that parabolic shape is going to be formed. This is going to be the actual fish motion that's going to occur. But when we deal with these problems, we deal either with the x right here or we deal with the y. We don't deal with them combined because this is a parabola. It's not a triangle, so I can't do SOHCAHTOA with this. Not that overall. When you do the honors problems later on, you'll do SOHCAHTOA with parts, but not for the whole motion. So how fast is the fish traveling vertically? I'm going to erase this part so I have more room. Traveling vertically, when it hits the water, this is going to be at the end, the final y. So what I'm going to do is I'm going to go ahead and solve for VFY right here. And I'm going to try to pick off as much information, and you should be looking at your projectile motion, or this equation will actually be just in your acceleration equations. What's going to be useful here, I can actually pick more than one equation, but I'm going to go with this information right here. And you're going to see an equation on your equation sheet that says VF equals VI plus AT. That is specialized to go with these. VF is nothing more than VFY. VI is nothing more than V initial y. And A is nothing more than the acceleration due to gravity, and T is just time. So I could take that equation and then pull out the VI is 0. The acceleration due to gravity is 10, and it's going to do that for 4.24 seconds. So if you accelerate at 10 meters per second every second, you're going to accelerate up to a velocity of 42.4 meters per second. So this is, and it would be going down. Once again, we were using positive values going into this. So when it hit the ground, it would be going 42 meters per second. And then how far horizontally forward would the fish land? We're going to use the equation that's on if you have my equation sheet, it's going to be on the projectile motion section, x equals vx times t. It's derived from v equals x over t. And you just plug in your values. You're using the x value for velocity of 25. You're using the time of 4.24 seconds. And when you do that, 25 times 4.24, you get a total x, or total displacement, of not that, but 106 meters. So that's your answer for this question right here. So let's keep on going. This is important just to kind of understand what you need in order to figure out a question. So what variable, I'll go back and read this in a second. What variable information was given in the question which was required to determine how far out the fish would land? So what information did I need to find out that the fish was going to fall that distance? Well, first of all, I needed my Vx. I needed my velocity going forward. So my Vx was 25 meters per second. So that's going to tell me how far forward I'm going to go. The next thing I needed was my Y, how far down it was going to fall. But another thing that was really important here is if we were on the moon or somewhere else, the G might be different. But we used the G of 10 meters per second squared in our last problem. So this is just kind of making you think about what did I need? Well, I needed my horizontal velocity. What else did I need? I needed my height I was falling from. With the height, and with this last other thing, G, with G and height, I could figure out the time, and so therefore I don't really need time because I can use the Y and the G to figure out time. So these are the three variables I need to know exactly where that object's going to land. One thing I don't need is mass. So would you need mass? No. We're going to assume that we have really aerodynamic objects or that we're in a vacuum, which is not always the case, but in these problems we are. And so the mass doesn't matter, or else the mass is not in the t equals square root of 2y over g equation. If mass was in that equation, then we would need it. So using your givens list or your equation sheet could help you kind of figure things out. Give 3 examples of a projectile ball being thrown. Could be a marble rolling off a table. Could be, I don't know, just a pen being thrown. Let's see, I used a lot of the bird dropping something. Dropping, let's go with a fish. Now, the dropping of the fish is the projectile. The fish itself is the projectile. The marble is a projectile once it leaves the table. The ball is a projectile once it's thrown. The key things that they need is they need to be in the air. They have to be in the air. Number 2, only influenced I can't spell. Influenced by gravity. Specifically the force of gravity, which leads to the acceleration due to gravity. So what I mean by that is it can't be a plane with a thruster, rocket with a thruster, or something propelling it through the air. So 2 main things you need for it to be a projectile. Anything that's in the air. It could be a piano falling through the sky. It could be anything in the air that doesn't have its own power, causing it to move against what gravity is making it do. What happens to horizontal velocity after a projectile is launched horizontally? It's going to stay the same. And we call that constant velocity. Let's go and just add that. It's like constant x velocity because it's talking about the horizon. What happens to the vertical velocity? Well, this is going to be accelerated by gravity, meaning it's going to change. On the way up, it's going to slow down, and on the way down, it's going to speed up. Which is affected by gravity, it's going to only be the y-axis. So when we write down gravity equals 10 meters per second squared, we either use the word down or we write the arrow down. Okay, in this problem, you throw a ball forward at 20 meters per second from a height of 1 meter. How much time would it take to hit the ground? Just do an x and y givens list. And you're throwing a ball forward, so if you're doing an x and y givens list, the Vx, because it's forward, it's going to be horizontal, it's going to be 20 meters per second. And it's going to be from a height of 1 meter, so y would be 1 meter. How much time would it take to hit the ground? And so we're asking for time to hit the ground, time to go down. A few other givens we can throw in there. G is equal to 10 meters per second squared down. We're not going down at the beginning, so the initial velocity is 0. And we're trying to solve for time, and there's an equation you can find only when VIY equals 0, and that's t equals square root of 2y over g. And so the square root of 2y over g would be, let's replace the y with the 1. the G with the 10, and it's going to be 10 down and 1 down. So we can use positive values for that, and you get 2 times 1 equals divided by 10, and then you take the square root of the answer, and you get 2 times 1 divided by 10. And I get 0.447 seconds. So that's going to be the time it takes to fall from 1 meter height. Now, if you drop a ball from the height of 1 meter, you're going to have exactly the same given. So we would do the exact same equation. We'd have everything from right up there, and we would also get a time of 0.447 seconds. And it doesn't matter how fast you throw the ball, it's going to do nothing. So it does nothing to the time it takes to hit the ground, no matter how fast this Vx is. If it's really, really fast or really, really slow or nothing, for the sake of 7b, it's not going to change the... Okay, the next kind of problems we're describing a vector. If I saw something like this, I would put the hypotenuse to 20.6 meters per second first, and then I would put the degrees, 14 degrees, and here I would put blank of blank, and look at the last thing, the thing that's coming out of the origin dot. What's coming out of the origin dot is west, and we're going north of west. So this final answer for this one would have been 20.6 meters per second, 14 degrees north of west. What is the horizontal component of the vector drawn here? Well, in this case, the horizontal, remember the horizontal is going to be left and right, vertical is going to be up and down. So we have to look at this, and the horizontal component is going to be that adjacent side. And so and this is going to be our hypotenuse. So the horizontal component, or in this case would be Vx, but the horizontal component is the adjacent side, which equals the cosine of the angle times the hypotenuse. Well, the cosine of the angle, which is 14, times the hypotenuse, which is 20.6, is going to be the answer. Now make sure that your calculators are in degrees and not radians, because we're going to be typing 14 degrees in there. Cosine 14 multiplied by 20.6, and we get 19.99, and that's going to be meters per second, because the answer, the information we were given here, because that 20.6 is meters per second, it's still going to stay meters per second. Now the vertical is going to be our opposite side. Once again, the triangle opens to the opposite side, and we have opposite and hypotenuse in the opposite equation. Opposite equals sine of the angle times the hypotenuse. And so sine of, in this case, it's 14 degrees, and our hypotenuse is 20.6 meters per second. So sine of 14 times 20.6 equals 4.98, and it's going to be meters per second again, because the hypotenuse was in meters, the 20.6 was in meters per second. Let me circle my answers so they're clear to see. I think I'm going to provide you the PowerPoint on top of just me speaking, so you can go where you need help and just listen to the video as you need it. Okay, so next, this is another type of problem. We're going 35 meters west followed by 60 meters north. So we're drawing a complete vector diagram. It doesn't have some sort of angle in here, so we don't have to break it into anything else. We can just go ahead and draw an origin dot. And I told you in class that just so we can check our answers, do the first one first. So we're going to go 35 meters west, and we're going to follow that up by 60 meters north. We're going to draw the resultant, which will be from start to finish. We'll draw the angle closest to the origin dot, and now we're ready to start solving. We're going to start solving for c first, which is a squared plus b squared, the square root of that. So that's going to be square root of, in this case, it's going to be 60 squared plus 35 squared. And so the hypotenuse is going to be 60 squared plus 35 squared equals, take square root of that answer. It's going to be something between these two numbers because it's a hypotenuse. It's not going to definitely be bigger than the maximum, which would be the added of them. It's going to be 69.46, and that's going to be meters because we had meters up here. Since we had meters up here, that's going to be meters right here. Now we want to find the angle. The angle is inverse tangent, so tangent -1. Most calculators have a shift tangent 1 of opposite over the adjacent. So that means we have to determine which one the opposite and adjacent is. So this angle closest to the origin dot opens up to the opposite, and our adjacent is going to be on the side, and our hypotenuse we already solved for, and we're not going to use that here. You could once you solve for it, but there's no need to. So it's tangent of -1 of the 60 over the 35. So inverse tangent 60 divided by 35, close parentheses, and I get 59.74 degrees. And so I'm ready to now come up with a final answer. My final answer would be 69.46. So I'm describing the resultant when I say my final answer. 69.46 meters. And then I go ahead and I state the degrees. 59.74 degrees. And then something of something. In this case, it's going to be, I have west coming out of the origin dot. It's going to be north or west in this case. So there's your final answer that I'd be looking for if I didn't specify just to give me magnitude. If I specified give me magnitude, you'd give me the first part. If I specified give me the angle, you'd give me the second part. And if I specified give me the direction, you'd give me the third part. Okay, which angle would you shoot a projectile to reach the furthest distance downrange? That's just something to memorize, 45 degrees. Shoot something at 45 degrees, it's going to get as far downrange. And so that's going to be x. Furthest downrange at that 45 degrees. And then now just asking some questions about this little diagram I have here. What's horizontal velocity at c? Well, if I know the horizontal velocity anywhere, it's going to be the same everywhere. So in this case, it would be 12 meters per second because it's not going to change. So this is a ball being thrown up into the air, following this path right here. But each point of this, the A point, the B point, the C point, the D point, can be broken in to what you see here, which is the horizontal and vertical components. What you should see is that the horizontal, this horizontal doesn't change. It's going to be 12 anywhere I see it, 12 meters per second. But the vertical slows down on the way up, disappears, and speeds up on the way down, the whole time being accelerated by g, which is 10 meters per second squared down. This is an unchanging value. It's the velocity that changes because of that value. Where's the minimum velocity? Notice how at b, you have minimum velocity, and it's only made up of that 12 meters per second vx, the horizontal velocity. And so it's going to be 12 meters per second. And then what's the vertical velocity at point D? Well, at point D, it's going to be 23 meters per second down. If you're with me working some honors problems later on, well, that down would have to be negative. But for the sake of just wording, negative is not really useful unless you're actually doing a problem, because you can call down positive or negative. So the wording is going to be better. What's the horizontal velocity at point D? Horizontal velocity at point D, well, that's not going to change back to 12 meters per second. What's the acceleration at point B? Once I see acceleration, it doesn't matter what this is. Acceleration is going to be 10 meters per second squared anywhere, and that's going to be down. What's the vertical velocity at B? Well, at that moment, the vertical velocity stops. It does have velocity as an x velocity, but its y velocity is 0 meters per second. Does not mean it's stopped accelerating. It's still going to change its velocity. It's not going to stay at 0. It's going to start accelerating and start changing its velocity downwards as it keeps on going. What's the horizontal acceleration when the ball is maintained a constant velocity? Okay, horizontal acceleration, first of all, will tell you something. There is no such thing as horizontal acceleration in these problems that we've been working with, because we've been kind of pretending like it's a vacuum. Gravity works downwards. So, and another thing that would tell you, if it's constant velocity, watch out for these words. If it says constant velocity, not constant acceleration, because that means something else. If you see constant velocity, that means a equals 0 meters per second. So there's two things that are going to give this away. Left and right, 0 meters per second of acceleration. Up and down, it's going to be down 10 meters per second squared. So what's happening to the vertical speeds? We're just talking about this right here, vertical speed on the way up, and that's going to be slowing down. And then what's happening to the vertical speed on the way down? It's going to be speeding up. And once again, because of it's going to be changing, it's going to be accelerating downwards at 10 meters per second every second, which is why it slows down on the way up, because it's being pushed down, and then on the way down, it's being pushed down still, so it's speeding up on the way down. So just watch out for the word constant velocity. When these two are tied together, that's going to be important. That tells you 0 meters per second. But horizontal acceleration, the gravity is affecting the y-axis. Okay, so if you're in CP, you don't have to watch this video anymore. If you're in honors, I'm going to show you how to do a problem like this. Add the following vectors and determine the overall resultant. So you should be able to add vectors in CP. In my classes, of course, different classes. If you're with another teacher, you might have to do this as well in CP. But here you have two vectors, and we have to break up the vectors. So I'm gonna go ahead and I am going to deal with these separately. I'm going to go ahead and break this into an X and a Y component. So I'm going to draw it out. So you have north of east. So it's going to be east first, then north of east. Once again, the angle, the 45 meters at 20 degrees. Anytime you see that the angle is next to the vector, it's not going to be like this. This will actually be just north is going to be an x-axis or y-axis. But this is going to have both the x and y-axis to it. So I went ahead and drew north of east. I went ahead and drew the last thing first, and I drew the north next. And then I'm going to go ahead and finish off this vector. I'm going to put 20 degrees right here, and I'm going to put 45 meters on the hypotenuse. This will always be triangle. So this side is 15.39 meters up. Let's go ahead and figure out this side. This is going to be the cosine of the angle times the hypotenuse. Once again, because it's the adjacent side, and adjacent equals, so let me just write it out like you probably should write it out. Adjacent equals cosine angle times hypotenuse, and let's go ahead and plug those in. Cosine of 20 degrees times the hypotenuse, which is 45 meters. So cosine 20 equals times 45 equals, and I get 42.2, let's go with 9, meters. And so this is 42.29 meters. So now we have that plus, and I'm no longer concerned with this. I just broke away, I broke this triangle, this 45 meters into 42.29 to the right or east and 15.39 meters north. And then I'm going to add that to, so this right is broken into these two values. This right here is going to be a single x value, single y value, and this is going to be a value of 80 meters. And I'm going to go ahead and say north, I'm going to turn it into positive 80 meters. So this is going to be y is equal to positive 80. I'm going to have to mix that in with this y. And this y is also going north. And so this is, since this is north, this is going to be positive 15.39. We're going to find an overall y-axis. So what you see is that you have this vector that's going directly north, right here, and this vector that is going east and north. Well, we want to go ahead and put the y-axis together, which we're doing, and you can look back at some of my old videos from the previous lessons if you're having trouble kind of seeing this, because they're a little clearer, a little more step by step by step, and not mixed up, jumbled up like this. So what we want to find, since positive represents north, we're going to add those together, and we're going to get plus 80 plus a positive 15.39. And once again, that positive there just represent north. Normally you just write down 80 plus 15.39, which is fine for what you're doing on your paper and on your test. And we add those together. So this is just 80 plus 15.39, and we're going to get 80 plus 15.39, and we get 95.39, and this is going to be meters, and this will be a positive value. So what this ends up being, the y-axis is going to end up having 95.39 meters north. And then if you take a look at the x-axis, there's only one x-axis here. This 80 meters north had no x-axis, so there's going to be a single. So this would be the total y right here, and then the total x we're going to have to draw in. We're going to have to do it 2D motion. So this was 42.29, and this would be north of east. This was east. And now we're ready to go ahead and redraw the triangle. So this is where I'm just running out of room. We're going to go ahead and redraw the triangle with the total x and total y, and I'm going to go ahead and do it here. I'm going to do the x first just because it doesn't really matter which one I do. So we have 42.29 meters east, and we're going to follow that up with 95.39 meters north. And we can turn this into a right triangle. We can put the angle in here, and this is like one of the CP problems earlier now. We can go ahead and figure out our hypotenuse, which is a squared plus b squared. And so c equals the square root of 95. It doesn't matter which one's a or b, but 95.39 squared plus the b in this case is 42.29, and that's going to be squared. And so we get a hypotenuse of 95.39 squared plus 42.29 squared equals, take the square root of that answer, and I get a value of, I don't know what happened there, let's do it again, square root of the answer, and I get a value of 104.34, and this would still be meters because it was meters before. Let me just type that in again just in case. 95.39 squared equals plus 42.29 squared equals, take the square root of that answer, and then I get 104.39. We also want to figure out what the inverse tangent is, the angle is, and then we do the inverse tangent of our opposite over our adjacent. And so it's going to be inverse tangent of 95.39 over 42.29. And we're going to get an angle of, so inverse tangent 95.39 divided by 42.29. I get an inverse tangent, the angle is 66.09 degrees. So it's kind of getting crammed in there. And so we have a overall 104.34 meters. And so let me kind of try to cut this so it's kind of separated, but this is a little jumbled up, and it's going to be at 66.09 degrees. And this one, in this case, it's going to be something of something. This is going to be east. It's going to be north of east. So 104.34 meters, 66.09 degrees, and this is going to be north of east. Once again, east is coming out of the origin dot, if you want to think of it the way I kind of said it before. So it'd be north of east, and so this would be your final answer, final complete answer. Now on a test, be careful, because if it's on E-class, I might ask you, so what's just the north component, or what's just the east component? Because and so you have to watch out. You might have to put together, in this case, what we did earlier was we put the north here together with the north that we broke out of this one right here, and we got our overall total north. So just be aware, be ready to do something like that. Okay, so lastly, a soccer ball is kicked at 30 meters per second, 28 degrees. Let me just make sure I have enough information. Soccer ball is kicked at 30 meters per second, and the angle was 28 degrees above the ground or above the horizon. And this is going to give us, this is a projectile motion problem. This is going to give us a Vx, and it's going to give us a Viy. So right off the bat, we know we're not going to be using that t equals square root of 2y over g because we're going to have a y information. So we have our VIY and Vx. Well, this is going to be the opposite side. So if we can figure out the opposite, which is the sine of the angle times the hypotenuse. So I'm just going to write down, well, let me answer the first question. This is going to be the adjacent, which is equal to the cosine of the angle times the hypotenuse. So the Vx, which you see there, is going to be the adjacent, which equals to the cosine of the angle times the hypotenuse, and the cosine of the angle was 28 times the hypotenuse, which was 30, and we get cosine of 28 equals times 30, and I get 26.4, I'm going to go with 9, and that was meters per second because I had meters per second plus because this is velocity. So 26.49 meters per second. Now our VIY, once again, the Vx doesn't change, so that will be our x in our x-axis in our next part of the problem. Well, the VIY is going to be the opposite, which equals to the sine of the angle times the hypotenuse. It's going to be the sine of 28 times the hypotenuse, which is 30. And we get, so sine of 28 equals times 30 equals, I get 14.08. This is going to be meters per second. So what this is going to do, this is going to help me populate a givens list for our next problem, x and y. Soccer ball, if it went up, it stops, then comes back down. Well, the VFY is going to be 0 at that highest point. And so now we can go ahead and we can find an equation in the 1D motion section that's related, that has the V initial, the V final, the displacement, and has acceleration, and this is what you get. If you want to see it specialized for these exact givens, it would be this right here, VF y squared equals VIY squared plus 2GY, but the same thing is what you see right above it. Plug in our values that we see over there, and we get 198.20 equals 198.25 minus 20y. So this is a plus 2 times a negative 20, which would be plus negative 20. So we just get rid of the plus and we add a minus 20y, but we can't put these together because this is 20y's and this is just a number, 198.25. So we're going to subtract the 198.25 from both sides. And when we do that, we're going to end up getting negative 198.25 equals negative 20y. We can divide out the 20 from both sides, and we get negative 198.25 over negative 20, and that ends up getting y equals 9.91 meters. So when we think about how high the soccer ball is going to get, it's going to get 9.91 meters off the ground, being our y, and so that's how you solve this problem. But the difference here is that now we're not going just to the top. We're going to come back down. So you need to realize the VIY and the VFY are comparable, but the VFY is going to be the opposite or the downward version. So this is going to be going down of the initial. So we're going to have a VFY of negative 14.08. So it's now going down, and that's because of our gravity, which was down 10 meters per second squared. And we can go ahead and we can use that to find time. And then once we use that to find time, we're going to use that to find how far downrange. Then we're going to finally find out how far downrange that object's going to be. So we'll start this the same way. You have the VI, the VF, the G, and T. So VF equals VI plus AT. Once again, if you don't like seeing it that way, that's the same as VFY equals VIY plus GT. So same exact equation. And when you plug that in, that's going to be VFY is 14.0 or negative 14.08 equals 14.08 plus negative 10 times t. And we're going to subtract 14.08 from both sides. That's going to get rid of this. And we're going to have, I'm just going to work this over here. When you get to it, it's going to be negative 28.16. So that's those two added together. And then that's going to be over negative 10. And so you're going to get a time in the sky of 2.816 seconds. So that's how long it has to fly forward. And we're going to go ahead and we're going to put that into the x calculation. X equals vx times t. So that's going to be this 2.816 seconds. We solved for that. We now took it into the y-axis. We're now done. We landed. Now we're trying to figure out how far forward we're going to go when we are traveling at 26.49 meters per second for 2.816 seconds. So it's going to be 26.49 times the time it took, 2.816. And we get our final answer of the study guide, 26.49 times 2.816, and I get an answer of 74.595. So I'll just go with 74.6 meters. So it's going to land 74.6 meters downrange. Let me just write that neater. 74.6 meters downrange is going to be your final answer, and that's how you do those